Right, so thanks for coming on board with this one, Andy. I know you've done this one a couple of times, but it'll be good just to share it under the data bog and slide preparation banner as well. Thanks to everybody who's turned up, and if anybody's watching online, thank you. So we're looking at Andy Cutler and how to make your Synapse Analytics proof of concept a success. And I think, Andy, take it away. The time is all yours.
Okay, there we go. Thanks, Richard. Yes, it's data toboggan user group time. So just making sure that everyone can see my screen okay and see the up and running slide deck.
Yep, perfect.
Brilliant. Thank you very much. Yes, so thanks everyone for attending. We're getting to the business end of the year, so back up and running with Synapse Analytics at Data Toboggan. We've got two events coming up. Richard will probably talk about those events at the end of the session. Two very different events as well. Now, yes, I did this session at Data Relay, brand new session. However, Data Relay isn't recorded. So it's an opportunity to get this out there, because the actual content that backs this session is actually pretty new as well. I know time flies a little bit, but it's probably, I'm going to say, less than a year old. I'm just going to move my Teams information over to, just bear with me, please.
That's one of the things about Synapse, though, isn't it? Is that it changes so often, and there's always new stuff. So it's kind of really important to get on top of that curve, get ahead of that curve, and get it out there as soon as it comes out.
Yes. And in this case, so what was interesting, I asked a question. So I asked a couple of questions at Data Relay. I said, who is currently using Synapse? And it was a few hands went up. And then I asked, well, who is looking to implement Synapse? And half, a little over half, put their hands up. And of course, Synapse has got quite a few components. And then I brought up this documentation that I will show as we go through. And I said, has anyone seen this documentation? And not a single hand went up. And I think we were in the Microsoft campus at Reading, and I did joke about Microsoft marketing and said, maybe you need to put some of this front and center in your documentation. It's not all about the technical aspects, it's about how you implement as well. So that's what we're going to go through. Yes, there are some technical parts. We're going to have a little demo at the end. One part around infrastructure. So Richard will like that. Just joking. And one part on and one part on the data loading patterns as well in dedicated SQL pools. So this is called Up and Running, how to make your Azure Synapse Analytics proof of concept a success. So my name is Andy Cutler. Independent, consultant is just a fancy way of saying I just work for myself, really. If you scan the QR codes, that will take you to my Twitter. My Twitter is Mr. Andy Cutler, and I blog mostly at serverlesssql.com. So that's all about Synapse Analytics and occasionally other services that attach into Synapse, like Power BI and like Purview, and part of the Data Toboggan team as well. So we're going to break this session down into three parts. So like I said, yes, we've got a demo at the end, but we're going to look at what a proof of concept is, just a little description, just to kind of set the scene for when we look at what Microsoft have provided in terms of these playbooks. And that is a piece of documentation called Success by Design. It is split into two parts. We're going to concentrate on one part of it, but I'll also call out the second part as well, because that's equally as useful. So first, when I started to research best practices in how to implement a Synapse Analytics project, I was actually given a blog post and a quote I found in that blog post that kind of resonated with me. And I've probably been guilty of treating a proof of concept like a hack. Now, Matthew Adams works for Engine. Actually, the blog was sent by his partner, Howard, at Engine, and it really sort of stuck out because, yes, I think I've treated a proof of concept a little bit like a quick hack. I've just got something up and running and said, well, here it is. Here's the proof of concept. Without actually treating the proof of concept with the proper respect it deserves and the technology that you're using. So sometimes if you're hacking something together, you might not be representing the technology in its best light. Now, yes, we love things to just work. We want to push a button and it's just going to be amazing. But, you know, for the most part, that's true, but we can also help things out a little bit. And there are some ideal ways of doing things, and there's some some hacky ways of doing things. Okay. And when we look at dedicated SQL pools, that is probably very, very important. Okay. So there's a couple of concepts. One of those concepts I'll go through in the demo, which kind of highlights the issue if you're just trying to sort of get something up and running by hacking it together. Now, of course, I have to put a dictionary definition in here, right? So what we're looking to do in a proof of concept, okay, we're trying to demonstrate something. We're trying to demonstrate that, you know, a concept, you know, a business process, a bit of software, could be anything. You know, we could be buying a car and our test drive is the proof of concept. I have a set of goals that I need this thing to pass before I consider it a success, and I buy it, move into production. Okay, so that proof of concept description kind of covers, you know, a broad area. So when we look at Synapse, what we're looking to do is, firstly, we've got to set some goals. Now, those goals are going to be based on requirements. Okay, now when we look at this success by design, these kind of requirements and goals will make sense in the context of the whole playbook. But ultimately, we're looking to see whether Synapse Analytics is going to solve and meet a set of requirements and goals that the business has set out, and perhaps the technical team as well. Now, going back to that concept of hacking things together, you know, are you really defining goals when you're doing that, other than getting something working? So with a proof of concept, we really, really want to define the goals, okay? Because ultimately, how do we match that against an outcome? Yeah, and decide whether it's going to move forward, ultimately end up in production. So I went to Twitter first because I had a little thought about the definition of success. Okay, so even before I started to get into the Synapse Analytics side of things, I sort of asked, okay, what do you define as success in a proof of concept? If someone stopped you in the corridor or, you know, a virtual Teams meeting and said, was that Synapse Analytics proof of concept a success? Based on what you've done, how will you answer it? So the majority of people said, what we need to happen is we need the proof of concept to complete. Yeah, if it fails halfway through, well, it's been a failure, but how do we define that success or failure? Has it failed because we just couldn't get it to work? Or has it failed because it didn't meet the criteria? It wasn't fast enough. It didn't meet our needs. So people said, look, you've got to complete the POC, then evaluate the criteria, then you can say whether it succeeds or fails. It's like an experiment. If there are any, data scientists, a data scientist or scientist, in fact, they start an experiment and they need that experiment to conclude. They need to finish that experiment. Then they can evaluate the results. If the test tube explodes halfway through, well, either number one, they're going to have to run for their lives, or number two, it's not completed and they can't get to a conclusion. And again, going back to that whole thing about a hack, where does a proof of concept sit in the development process? So before I carry on with this slide, I had a conversation with a guy called John Martin at Data Relay. And he made a very good point and said, well, actually, your hack is it's before the proof of concept. It's like you're getting something working, and then that could move into a proof of concept. So it's not really an isolated piece of work. Okay, so if we want to treat a Synapse Analytics project with the respect it deserves, like any software implementation project, we have to ensure that a proof of concept sits in a product development process. And really, a proof of concept is an initial basic working version, right? We're getting something working and meeting a set of goals and criteria, and then we can move that into a minimum viable product. Now, I see the differences between these two as a proof of concept is not in production, whereas the minimum viable product ultimately will end up in production, or it hopefully should end up in production, because that minimum viable product has the set of features that the business have defined as the first version, and then you can iterate on that. So really, that proof of concept can lead to the MVP. They're not one and the same. We've got to separate them. Now, when we come to scope, so this is what we were talking about earlier around all the services and all the features of Synapse Analytics, because guess what? We've got serverless SQL pools, we've got administration, permissions, we've got dedicated, Spark pools, data loading, network security, encryption, querying, Delta Lakes, BI tools, user permissions, maintenance. I've purposely overloaded that slide. I've committed the cardinal sin of a PowerPoint, which is throwing loads of words on there, because that's what you'll end up with. If you start a Synapse Analytics project, you will see all of these concepts, all of these terms. So what are you going to pick? I mean, obviously, that's going to be based on your workload. Are you migrating? The definition of the project. But ultimately, if you're tasked with a proof of concept, so what do you do with all of these moving parts and all of these features? Create multiple proof of concepts. So what we can do is we can group some of those services, some of those features that we've identified. Okay, so this isn't creating a Synapse proof of concept. It's not about testing every single service and every single feature. You've got to go through a bit of a due diligence in identifying the products and services and features that you'll use within dedicated within Synapse based on your workload. But what we can then do is start to group those together. So a proof of concept one, we could just have a very, I'm not going to use the word simple. Sorry, that's the wrong word to use. A reduced set of services and processes that we would like to test. So we could use dedicated SQL pools and load some data and query that data. Okay, limit that proof of concept to just those two things. We've been told, well, we've got some data in the data lake. We're using Dynamics and the Dataverse, so we've got some data available there. We've got some streaming data coming in. So you'll need to add something to read data lake data on the fly. Well, of course, serverless SQL pools is a service in Synapse that can read that data in the data lake and the Dataverse. Don't just try and shoehorn that in to your POC with the dedicated SQL pools. Create a separate POC because it's got its own set of configurations. It's got its own set of considerations that we have to go through. And then also we've got the other features of a project with Synapse that we need to look at, like user permissions, like network security. Okay, now this is just an example 3 proof of concepts that I've put in there. It could be perfectly valid that POC 3, the network security and user permissions, is actually the first proof of concept. So let's prove that Synapse Analytics can be locked down and can be secured as per our organization's requirements. That's the first proof of concept. Okay, because when you're locking down Synapse Analytics, there are network configurations and settings to go through. It's not a trivial matter. So try and keep it realistic. Just pick an area of Synapse, pick 1 workload, 2 workload types that you want to trial, you want to include in your proof of concept, and then gate them. So make sure 1 completes before you move on to the second, in whatever logical order makes sense for what you're doing. So we come on to what Microsoft have provided. This slightly hidden documentation. It started as a GitHub repo with some PDFs, and they've migrated it into the Microsoft documentation. So you will find it. Well, actually, what I'll do now, that QR code will take you to the Success by Design documentation, but it's within the Synapse documentation online under a section called Guidance. And it was created by the CSE team, the Customer Success Engineering team. So these are the people that I would say are at the coalface of project implementation. So these are the people that are working with clients, that are understanding their requirements, that are then working with the software configurations to match what the business need. And they've come up with some best practices, some experience in the field around the best ways of running a project, specifically around that platform. So in this case, Synapse Analytics. And it's split into 2 parts. So this Success by Design has 2 areas. We've got the playbooks. So we've got the Azure Synapse Proof of Concept playbooks. That's what we'll concentrate on today. But there's also an implementation Success by Design. Can be used totally separate. So that implementation Success by Design, I'm not going to talk about it too much, but essentially that is a list of validation criteria against various aspects of your Synapse project. So number 1, your Azure subscription environment, your Synapse workspace setup and configuration, how you're loading your data, how you're configuring your security. Now, some of those implementation criteria can be useful to the proof of concept, but it's not mandatory. That implementation Success by Design can be used for proof of concept, can be used for your MVP, your UAT, your go live to validate what you're doing. But we'll concentrate on the proof of concept playbooks. And we've got 3 playbooks currently available that cover the 3 main compute engines. We don't currently have playbooks for the Data Explorer engine, ADX, yeah, the new engine that's been added into Synapse. So we have dedicated SQL pools where they talk about SQL pools in the frame of a data warehouse. We've then got serverless SQL pools where we're looking at using serverless SQL pools to query data in a data lake. So ad hoc data exploration, the concept of the logical data warehouse, where we want to create data warehouse structures, but we don't want to move and transform data. We're going to leave it where it is. So we're not moving data around, and we can query that where it sits. And Spark pools. Okay, so if you're looking at using Synapse Analytics for your Spark workloads, again, there's a playbook for that. But as I've said, there's no playbooks currently for pipelines, aka Data Factory, the Data Explorer pools, or any of the Power BI integrations. So we're concentrating specifically on the 3 pools that are available. So part 1 of the playbook is all about preparing for the POC. Okay, so at this stage, we're not executing a proof of concept because we need to create that proof of concept. We need to document everything we're going to be doing in that proof of concept, or proof of concepts, you know, if we've got multiple proof of concepts that we're putting together. So some of those are going to be tasks that we have to do before, in my view, we start to get to the good stuff. We start to get to the architecting and developing. So who in our business is sponsoring us? Who in our business are the people that really want to drive this project, that are the people that we go to for help in broadcasting what this project is going to do to the business and the benefits of this project? Do we have anything that's going to block this project? Do we have any kind of organizational policy? Do we have any kind of infrastructure restrictions? What are the cloud policies? Okay, we can't just go off and start doing something if there are some policies put in place. We've got to make sure that nothing is going to block what we're doing with Synapse Analytics. Or if there are blockers, how are we going to solve, how we're going to solve those blockers and move on. And then the use cases. Now I'll put in brackets pain points as well. This is the crux about why you would why you'd be doing a proof of concept with Synapse Analytics, because what are the use cases? Do you have an on-premise data warehouse workload that is becoming difficult to maintain? You are not really getting the features within that environment, like integration with other services, machine learning, things like that. And have you identified that there are some pain points, some slow processing that makes you believe that moving to the cloud, moving to Synapse Analytics is going to be a benefit? So a list of what those use cases are. Because ultimately, if someone turns around to you and asks you, why are you doing a proof of concept? Just because isn't really going to cut it. You're going to need to list why you're doing it. What are the use cases? And then we start getting into the good stuff. So creating a high level architecture. So how are you architecting your Azure subscriptions, your development, your testing, your production subscriptions? How are you putting together your resource groups, creating your Synapse workspace, your storage? How is that all hanging together in your architecture? Do you have on-premises data sources? Are you going to have to use a gateway? So you start to put together a picture of how your architecture is looking. And then what data are you going to use? So unlikely that you're going to be migrating all of your data for a proof of concept. Are there some specific areas that you can migrate? Maybe it's a sales data set or a marketing data set, telemetry, something hopefully attached to some sort of business expert or subject area expert in that data as well, to help guide you when you're using this data. But it's also about the size of the data set as well. Now, Microsoft, they say try and test on 1 terabyte of data. Now, look, it's largely simplistic just to say test on a terabyte of data. I mean, you've got to move that terabyte of data around. Okay. So really, you know, if you can try and get a decent volume of data, sure, but I wouldn't really stick to a hard and fast rule of it has to be 1 terabyte. Now, when we're looking at considerations around migration, what's this project doing? Are you migrating from an on-premises system? Is this a greenfield project? Because ultimately, in your proof of concept, you're going to have to decide what parts you're going to engineer and develop. If you've got let's say an on-premises SQL Server data warehouse that's processing, do you really have the time right now to start re-engineering ETL processes if you need to get those working in Synapse? Ultimately, if you're looking at proof of concepting querying and querying speed, you don't want to go through a whole bunch of ETL refactoring just to get the data into Synapse and then to find out that, yeah, this isn't quite working out how our workload expectations. So previously, what I've done is I have processed dimensions, let's say in SQL Server tables. Once the dimension processing has completed, I've then bulk loaded those dimensions or the changes up into Synapse. So Synapse doesn't do any processing at all. And that's just enabled me to test processing, to test querying in that. And then we go back to making sure that our proof of concept has got some criteria that we can evaluate. We have some goals and some success criteria there. Do we need the data loading to complete in a certain time frame? Do we need queries that feed downstream systems to complete in certain times? These are our goals. These are our success criteria. Now we can create a testing plan and link that through to our success criteria. So if we've got a goal, we need a test for it. We might have several tests as well, but that testing plan, it kind of goes hand in hand with that goal. Yeah, pass the test, meet the goal. Timelines. So again, if we go back to that slide around splitting the proof of concept into several proof of concepts, that's really because we don't want to bloat the proof of concept. We don't want too much into that proof of concept that it starts to drift. And Microsoft have recommended 2 weeks. Okay, now this isn't 2 weeks in terms of starting this process. This is, let's say, 2 weeks in terms of several weeks before you've gone through this process, identified sponsors and high-level architecture, and you've created your testing plans and etc., so that Monday morning you're ready to go. Bang, you're going to start the proof of concept, load your data in and query. And who is going to be doing this? So you're going to need someone who understands Synapse Analytics. It could be, someone internal where, that's had some training. Could be Microsoft, could be, consultant. Who's project managing it? Is there a business analyst that's converting some of those requirements into technical requirements? Now, I've ordered these as kind of Microsoft have ordered them, made a couple of amendments, but ultimately this is not a hard and fast way of doing each and every task. You might want to make sure that you've got the relevant team members in place before you go through all this. There's no point starting any of this if you don't have any people that can do it. And then when we start to put the proof of concept into practice, the first thing we've got to do is our setup. Now, this is going to feed in from our high level architecture. So we need to set up our Azure subscriptions if they haven't already been set up. We need to set up our resource groups. We need to set up the Synapse Analytics workspace and configure that workspace to meet our needs. If that means including networking in there, that could be its own proof of concept. So the setup in itself becomes a proof of concept. And then for dedicated SQL pools, I've picked the dedicated SQL pools POC playbook. We're going to load some data. Now, again, Microsoft have recommended that what we do is keep that loading simple. We'll see that in the demo later on. And we're going to use a copy into data loading process where we're loading data external, that's been already exported to a data lake into Synapse Analytics. And then we can start to run our query tests. So we've got some sequential query tests. Now, these query tests are pretty simple. We've got a whole bunch of SQL queries that we want to test. We run those SQL queries in a SQL client of our choice. But we've got some tests that we might want to do concurrently, because one of the aspects of dedicated SQL pools is the concept of concurrency, how many queries can run at the same time. I think up to 1,000 queries can be queued, but it's how quickly those queries are going to be executed. And we've got tools like Apache JMeter. Okay, so actually there's a really good blog post where someone had tested serverless SQL pools concurrency alongside Databricks using Apache JMeter. And then this concept of mixed workload tests, this is where we're not just querying data at the same time, we're also loading data. Yeah, so we're loading data, we're querying data. So we need to do some testing around that as well. Now, we might find that we've loaded data, we've queried that data, but actually we need to maybe go back and optimize that data. So what this means is, in the world of dedicated SQL pools, we've got different ways of distributing data when we create a table. Perhaps we need to go back, revisit that distribution and change it. We might have some value-added tests. Now, Microsoft have put value-added tests in as things like user security. Now, I kind of feel that they're their own proof of concept themselves. So those value-added tests, I'd say, look at user security. Maybe that ties in with some of the things you're doing with querying, but ultimately it probably should sit as its own proof of concept to make sure that you're very clear on who can see what. So in its simplest terms, if we want to put this POC into practice, we're going to create and configure a Synapse workspace. We're going to create a dedicated SQL pool. We're going to load some data into that dedicated SQL pool. We're going to run some queries. Right, that's exactly what this dedicated SQL pool is there for. Get some data in, query some data, and then ultimately document query runtimes. Yeah, so they'll be our goals. So we've got that, big data set, or the several reports or some downstream applications that need data. How long does it take for dedicated to crunch that data and deliver the required data set? So I'll do one more proof of concept slide, and then I think it's time we jump into a demo. So in a timeline, if Microsoft have said, look, try and stick to a 2-week timeline for to make sure that you're kind of time boxing that proof of concept as much as possible so it doesn't drift. Yeah. So as I've said, setup of the environment is not included in a proof of concept timeline. In brackets, if setting up the environment is its own proof of concept. So for this proof of concept, if we're loading data and querying data, number one, maybe we've allocated 3 days to load data into Synapse. Maybe we've loaded data several times. Maybe we're trying different ways of loading data. Then we've got some days to do querying. Okay, so we've got 5 days. That includes running our sequential tests, our concurrent tests, our mixed workload tests as well. So we might be loading some data and querying some data at the same time. Then a couple of days to document and validate. Have we been able to successfully complete our testing? Do we have some timings? Can we document those timings? Can we validate those against the goals that we've set? We can jump into a demo. Now, for a proof of concept, you might actually be creating a Synapse workspace multiple times. You might create the workspace and sit now, okay, that's not really configured. So I can go and change it through the Azure portal. The Azure portal, the web-based portal, is really, really good at getting getting a service configured, but from a repeatable deployment perspective, it gets a little tiresome having to go through the same thing over and over again. So I've started to use Bicep. I'm not much of an infrastructure person really, but I've really started to appreciate Bicep in terms of creating a template and then just running the commands to deploy that template. So I can give my Synapse workspace a name. I can tell it what resource group to be deployed into. I can tell it what security configurations I need, all in a Bicep file. Now, I'm not going to go into Bicep too much, so all of this Bicep code is available on my GitHub, which in itself, the Bicep code is from another repository. Okay, so what we've done is we've set up, a whole bunch of commands to create storage accounts, create Synapse workspaces. Okay, but it's a repeatable template. So what I can do is I've already, nobody wants to see me copy and paste. No one wants to see me write out these commands. So we're actually going to copy and paste in. So I think I'm already logged in. I've already set my account. Now, what I need to do first is I'd like to go into my resources over here. So what I'm doing off the screen is I'm just deleting an existing work group that I created. So if I just scroll down and I'm just going to delete this resource group. Okay, and what I will do is I will say create. Apologies. I don't want to show what I'm doing because I want to concentrate on the Bicep template side of things. Okay, so I have a resource group called DHRG Data Toboggan. And I'm going to run an AZ deployment task and pass in this bicep file with the parameters. Now, the parameters could be things like the SQL administrator password for the dedicated SQL pool. It just means that I've kept all my configurations and my deployment script in a central place, and I can just run it over and over again to create, well, as many workspaces as I would like. I can put parameters in that prompt me. What I'll do, let me just run zoom it very quickly. So you can see down here, I've put a command in. So please provide a string value for location. I'm going to say, well, deploy my resource to UK South. We'll run that. Then what I'll do is I'll drag in my window in here and we'll go to the Synapse workspaces. Okay, let's refresh those. Let's go back to visual. So it's running. So I should see another workspace appear. Okay. Let me refresh that. Let's see what Visual Studio Code is doing. So it is running. So it might take a minute or so to start provisioning. There we go. DHRG Data Toboggan. So there's the resource group. And there's our Synapse workspace. Now, it's just got some auto-generated characters after that. So you can put in a Synapse name if you want into your bicep template, but this script kind of auto-generates a workspace name. So it's really useful if you just want to deploy multiple workspaces to test something. Okay, now if we go into that workspace, we can see that the resource is being provisioned. So I'm not going to do anything more with this workspace because I'm going to jump in to a workspace that already exists and carry on what we're going to do. So let's assume in our proof of concept that we've set up and configured our workspace. Our proof of concept is ready to go. We want to load data and we want to query that data. So if I'm just going to open up Synapse Studio on my existing Synapse Analytics workspace, let me just log in. And let's zoom in a little bit. Okay. Now what we'll do is I have some scripts already ready. The first thing that I'd like to do is create a user called Synapse Data Loader. It's a domain user, so it's from an external provider. I'm going to give it the various access that I need that user to do. So I need it to be able to insert data into various schemas. I need it to be able to create tables. I need it to be able to select data. And I also need it to be able to talk to the data lake. So that's why I have this grant administer database bulk operations. Yeah, that gives the user permission to go and load some data in from the data lake. And one of the most important concepts is workload management. So what I'm doing is I'm adding this user to a role called xlarge RC. The RC stands for resource class. And what that does is that actually allocates a certain amount of resources to that user when that user runs a query. So for extra large RC, that's going to allocate 70% of the dedicated SQL pool resourcing. So you kind of have to start to find a pattern in terms of your user behavior. So there'll be some users that you use for loading data and querying data as well. So finding the right balance of what resource classes to use is quite important in there. I'm going to run that script to create that user and generate all the necessary permissions. Then, just going to bring up Teams very quickly. Feel free, Richard, to jump in if there's any issues with what you're seeing at the moment. But what we want to do is we want to load some data in. Now, Microsoft have recommended keep it as simple as possible and use the copy into command. Okay, so this is Microsoft's recommended command to get data into dedicated SQL pools because it's pretty fast. Yeah, it's similar to Polybase, but it's much faster than Polybase. It can parallelize the query and it's fairly simple to use. Now, in these examples here, so what I'll do is I'm going to copy this script and log in using Management Studio. So I'm already logged in as that user. I'll probably need to connect again. Let's just connect. Okay, now I'm logged into that user as that user. Now I'm going to copy into raw schema. So it's just the raw data from the data lake. So I've got some dim date data and some dim product data. So it's my already sort of pre-formatted data that sat in the data lake, ready for me to ingest into dedicated SQL pools. I've got this statement, auto create table on, which means that if I'm using a file type of Parquet, it only supports Parquet at the moment. What it'll do is if that table doesn't exist, it'll create that table based on the schema within the file. So it's super, super useful to be able to create the table and import the data at the same time. So it's almost similar to the create external table or create table as select. So we're going to run that statement to copy the data from the data lake. So we've got 3,000 rows, the same for dim product. I'm going to run that. And then just to show the differences, I'm going to create a table. So I'm going to create a staging table for my fact data, really. And I'm going to distribute it by round robin. And I'm going to use, and it's a valid indexing strategy, but a heap, because that is the fastest way to get data into dedicated SQL pool. Round robin the data basically means it's just going to take every row and just put it on one of the underlying data distributions which underpin the storage of dedicated. And because that round robin process is random, it can just parallelize that loading as fast as possible into that table. So I'm going to create that table. And I've already preloaded some data. So there's just shy of about 1 billion rows of data already in the fact table. So I'm going to copy in data from a specific dated folder. So it's the change data, it's the new data. Okay. Now, all I've done is I've just removed the auto create table because that table, it already exists. It's already there. So what I can do is I can run that copy into statement. Now, this takes around 25-30 seconds to run, and that'll load in around 25 million rows of data directly into that staging table. That staging table doesn't have any data in it. It's just the staging table that we're going to load that data into. Oh, there we go, 20 seconds. So yeah, 24 million rows of data into that staging table. So then if we go back to Synapse Studio, okay, so we've loaded our staging data. Now we can load some facts and dimensions. Okay, so we'll do the same thing. I'm just going to copy and paste my GitHub script into Management Studio. And this is where I'm actually going to create two versions of my dimension tables, because I want to highlight the testing of data loading and querying when you're kind of optimizing the data. Okay, because you could be picking a way to distribute your data in dedicated, and you might actually find that you test number of different ways of distributing your data to find the sweet spot that meets the needs of what you're querying. Okay, so I'm going to create a dim date dimension based on that staging data. So ignore all this date add. It's just to align the dates with my fact data. So if I create that table, I'm going to do the same. However, I'm going to distribute the data differently. Okay, so this dimension table, I've done that round robin. And this table, I'm going to replicate it as well. So ignore the indexing. Okay, so I just want to concentrate on the distribution. Okay, so I've round robined the data here and I've replicated the data here. Now what replicate does is it takes a copy of the table and it copies that table onto the dedicated compute nodes. If you have several compute nodes, if you've scaled your dedicated SQL pool up, it'll make a copy of that table available on all those compute nodes, and it'll help to minimize moving data around. Now, that's a concept that, well, a concept that you can't even cover in a single session on its own. It's probably a full training day in and of itself. But suffice to say, I'm testing two different ways of distributing my data. So I'll create that table. Okay, and I'm going to do the same with product. Okay, so I'm going to create a product dimension. I'm going to create it with a round robin distribution, and I'm going to create it with a replicated distribution. So let me just run that statement. And the last thing I'll do is create the replicated product table as well. Okay, so what I'll do is I'll skip inserting the data from the staging table so we can get into the querying. But suffice to say, I would be importing the data from the staging table into the web telemetry table. So if we go back to Synapse Studio, we'll look at the queries. Okay, so what I'll do is I'll copy these two queries out here. Now, what I like to do is, there's the concept in dedicated SQL pools of, well, like many other systems, of caching a result set. So if you run a SQL query and then dedicated has got to do a whole load of work to generate that data set and return that data set, if the exact same query is sent to dedicated SQL pools, well, dedicated can just return the results from the cache if it knows the data hasn't changed. If it's the same query, data hasn't changed, get it from the cache. So what I like to do is I like to set that option to off when I'm testing. So I think it's already off at the moment, so I don't need to set it. But essentially what that does is that's just going to keep running the query without any caching, and that's going to give me a true picture of what's happening with the data. You know, what's the execution plan going to be? So I'll run this query, which is going to join my web telemetry fact table to my dimension tables. Okay, so these are the dimension tables that are round robined. Okay, so if I run that command, okay, we get it back in about 4 seconds. I'm actually going to switch to Synapse Studio to run that again. We run the query again. So we're getting, 2 to 4 seconds. Okay. I'm now going to run the exact same query, the same fact table, but I'm going to use the 2 dimension tables that are replicated. So if I run that, we're going to see 1 second, 2 seconds, 4 seconds back. Execute that again. So a couple of seconds. Jump into Synapse Studio. I think actually if I run the non-replicated, so I'll run it a couple of times, check the messages. So yeah, about 2.7 seconds to run that query. And then if I run the query that uses the replicated tables, yeah, 2.4, 2.3, yeah, so slightly quicker. So it's good to test various different distributions of your data during your proof of concept, because ultimately when you're designing the distribution of your data in dedicated, yes, there are some best practices, but you've got to be able to distribute your data to meet as many workload possibilities as possible. You might not be able to do all of them. Myself personally, I've been through the ringer any number of times trying to work out the best way of distributing tables. I've often duplicated tables and distributed them differently to meet different querying scenarios. Yeah, so when we had 5, so that's the end of the demo. I'm going to go back to the slides. So in the time frames that we had here, so 5 days for querying, you might think, yeah, that's actually quite a long time. I mean, what we're going to do, what we're going to be doing, spending 5 days querying? Well, you might be querying and discovering that data distribution is not quite correct in what you need to do. You're identifying your workloads and possibly going back and modifying how those tables are being distributed, but that's all within the constraints of your proof of concept. So I'll just put that up there. So again, yes, that QR code takes you to my Twitter. If you have any questions after the session, or you want some links to any other resources, just let me know. Tweet me, and I'll get back to you. But there we go. Thank you very, very much for watching the session. Thanks to Richard for inviting me on. Yeah, is there any questions at all?
I don't think we have anything from the chat, Andy. There was a bit about how much is all this going to cost me, and I kind of think you covered some of that in it's basically what you do and how much data you process, and there are a number of variables. But you actually did touch on a comment that which is, if you think you're going to need more compute, be honest with your sponsors up front. Don't tell them you can move like terabytes of data about and do some fun stuff when it's free.
Yeah,
if you run a reduced POC, so that's kind of a limited POC with a smaller amount of data, you can still get better, you still get good metrics off it, and that'll point you in the right direction. You don't have to always run full fat.
No, now pricing, considerations, and I am, I'm not just lying when I say this, but I am, I like to try and be as transparent as possible with pricing. What I would say is, if you're using dedicated SQL pools, okay, so we've got the pricing up here, right? If you can use the reserved pricing, okay, you can pay for this reserved pricing monthly, Yes, there is a, there is a penalty if you decide, if you enter in a 3-year agreement and after a year you decide, well, I don't want it anymore, there is a bit of a penalty. I mean, you don't have to pay the, it's a little, sort of cancellation fee, if you like. But if you look at the difference between prices, so this is GBP. So DW 500, that is the minimum recommended productionized dedicated SQL pool. Okay, because at DW 500, that is when you have your dedicated SQL pool on its own infrastructure. Anything under DW 500, you will share infrastructure with other organizations' dedicated SQL pools. And also that is when dedicated starts to come into its own in terms of separating out the compute node from the control node. And once you get up to DW 1000, that's where you start getting multiple compute nodes. But if you look at this, look, if you run pay as you go and you run it 24/7, and bearing in mind, dedicated SQL pools is a data warehousing service. And projects that I've worked on in the past, that dedicated SQL pool doesn't have to be running all of the time. In fact, one workload had dedicated running for 16 hours out of the 5 working days, and then for about 4 hours on Saturday and 4 hours on Sunday. Yeah, so it's a pausable service. You can run that through, Azure automation to pause and resume. But look at the savings if you say to Microsoft, okay, we're going to be using this for the next 3 years. Now, I kind of like to think that if you're going to be using dedicated SQL pools, and it's not a throwaway bit of software. You don't just decide, yeah, we're going to move our 4 terabyte data warehouse into dedicated, and in 3 months' time we might move it somewhere else. I mean, there's a possibility of doing that, of course. I mean, once you get your data into the cloud, yes, you can move things around. But you're probably going to be a bit more considered over the length of time that you're going to be using dedicated. And honestly, 3 years, that'll go by in an absolute flash. So you're looking at, under £2,000 a month to run that DW 500 24/7. Yeah, so you get a lot of those savings there. You've also got the concept of the pre-purchase plans. Okay. Synapse commit units, SCUs, another acronym. Right. So what these are, these apply to what services? Does it have a list of what services it applies to? No. Okay. So SCUs apply to dedicated, serverless, pipelines, etc. Treat one SCU as one of the currency that you're purchasing in. So, for example, if you spend £46,000, £46,898, what you're actually buying is £60,000 worth of expenditure. Okay, and then you can use it whatever you like. If you want to run dedicated for a few hours a day, if you want to run serverless, if you're running pipelines, then you'll get 16, you'll get a discount of 16% on that. Yeah, so I did sort of laugh when that was released, because there was nothing from the Microsoft documentation that told you how to map an SCU to what you're buying. So yeah, think of it as, if you're buying 5,000 SCUs, what you're actually buying is 5,000 £5,000 to spend, and it's cost you 4,373 of that. So yes, but you know what, that's the first thing that a CIO is going to, or CTO is going to ask, right? How much is it going to cost?
Yeah, the short answer is it depends.
Yes, it's going to depend. It's going to depend. But if you get some of that juicy savings up front, then you can considerably reduce your costs over time.
Cool. Thanks for that, Andy. That was really good. I didn't actually see the session at Relay. I just caught bits of it, so it was good to see the whole thing.
Great.
So I hope people got something from that, and obviously we'll post it up to YouTube in a bit. I'm just going to post a couple of links in the chat. One of which is the YouTube stuff from Data Toboggan, which has all the output of the last 4 12-hour conferences series that we've run. And we've got another one coming up in January 2023, 12-hour conference. I don't know how many tracks that's going to be just yet, but it's all the best Synapse content that you're ever going to see. We've got some great speakers lined up. There's also a link it will also be a link in the chat to our next event, which is a little bit different. So what we're going to do for the next event is we're just going to have 3 calls on a Friday, and we're inviting people to come along and just tell us their Synapse stories, their successes, tell us something they found interesting, tell us something they found that worked. We did it last year. It kind of worked, and we're just going to round out the year with something a little more informal. Those sessions won't actually be recorded, so if you want to get the good stuff from the experts, then you really have to be there. We're running it in three different time zones. There's one time for Asia Pacific, one time for EMEA, and one time for the Americas. And yeah, that's coming up on November the 25th, I think.
Yes, Friday.
It's a Friday.
It's a Friday.
So
Happy Friday.
In British time, it's like breakfast, lunch, and tea. So it's kind of snacky Synapse. We like that. So thank you for attending, Andy. Thank you for sharing all that with us. And we'll see you next time. And hopefully it won't be so long between the meetups.
Yes, thank you, everyone, and we'll see you soon.
Thanks very much, Andy. See you later.
Bye-bye.
Cheers. Bye-bye.